Good morning, everyone. I am Rinda Nariswari. Here in 4 Iccomset 2021, we'll present our paper entitled Model Development of Discrete Event in Circular System using Simmer Package in R. This paper is written by my partner, Dr. Anom Yudhistira, and I, Rinda Nariswari. The background of the research. Simulation models are used to study a system, especially if it's difficult or expensive or dangerous to study the system directly. Besides that, real systems are complex, almost impossible to study with analytical models, or that simulation is the last option that can be purchased anymore. The Simmer package is also equipped with automatic monitoring capabilities, with the default output in tabular form. This package also provides a rich and flexible API for R, centered around the concept of paths, which are common paths in simulation models for entity paths. Function trajectory, used to generate objects with class trajectory. However, the technique for building Simmer-based DAS models has not yet been complete, so it is effective for representing complex systems. The goals of the research are: describe the various capabilities of the Simmer package in R to run discrete event simulation or DAS models. Second, develop a technique for building DAS simulation models in general and circular simulation systems in particular, which are effective and can represent real systems in general good. Last, explore the simulation output using the Simmer package, both in the form of statistical summary and parameter estimation. The methods are using in this research. First, review the library to get a complete understanding of the R API application programming interface. The R API for Simmer isn't in the form of R functions. Second, review the literature to get a complete understanding of the environmental structure of the Simmer class. Third, build a chart or flowchart that describes the system. Fourth, build R script in their simplest form. Fifth, increase system complexity one level. Sixth, is it enough to represent the system? If not, please go back to step 5. And the last one is finish. Result and discussion. You can show the figure 1 that displays a simple system with single server. These timestamps can be obtained using the getMon_arrival function, which is present in the data frame object or table. The system has two types of simulation inputs, namely arrival or inter-arrival time and server activity times, or the length of time the server serves. System complexity improvement. Figure 2 shows identical parallel system. The number of parallel servers can be expanded to n more than 2 servers. Changes are only made to the addition of the number or capacity of resources, which is 2, while the other components do not change. How we added serial server and activity without resources? You can see the figure 2. Figure 2 shows serial system. And how to run serial system? You can see the function of R that display in this slide. Next, system with more than one entity type. Figure 4 shows the system with more than one type of entity. You can see that there are two jobs or tracks we define in research, job A and job B. Every job has a line for doing the systems. In the initialization component, there is no longer any value assignment for the old object, because this value is determined by the attribute value of each entity defined in the cross_NA and cross_NB trajectory. The function used is set_attributes, while in the third component, we adding resource and generating arrivals. The mount argument in the age_generator function is assigned a value of 2. So it can be monitored by the getMountAttribute function, which will provide a table for the attribute value of each entity. Circular system. Figure 5 shows the circular system from loading to unloading back and forth with two entities or tracks. The flowchart displayed in Figure 5 illustrates a hypothetical event from the origins of the loading and unloading back and forth and continues continuously. The following is an illustration of hypothetical system from factory to warehouse. Circular system. In the table 1, show the summary of system parameter value. We have two entities or two trucks, namely truck A and truck B. A company transports goods from the factory to the warehouse. The company uses two identical trucks, truck A and truck B. The activities carried out by each truck. The truck carries out the loading process at the factory, which takes 1 hour, then leaves for the warehouse with a travel time of 1/2 hours, and arriving in the warehouse and the unloading process is carried out, which takes 1/2 hours. After the unloading process at the warehouse, the truck returns to the factory with a travel time of 1 hour. The simulation is run for up to 24 hours. The table above provides the system parameter value. Parameter value consists of the amount of entity, there is the number of priority, and there is the loading time of load. This is unloading time on unloading, length of journey, load, unload, and length of journey, unloading, and loading. Replication. The following is an R script for model replication using the Lapply function available in the base package. The following R script to repeat 100 times. Confidence interval estimation. Based on the old R new data object, we get the average length of the entity in the system and in the queue, given by the EFG system time and EFG queue time columns, and the columns can be retrieved using the attach function. The standard error for the length of the entity in the system and in the queue, which can be approximated by the standard deviation of the mean per replication. The conclusion. Simulation development of the system will be easier to do by making a flowchart that clearly represents the system. All values of random variable and chains that occur to them can be retrieved from the Simmer simulation environment using the get_moon_ comment. In order to make the simulation results more interesting, it will be better to redevelop the discussion about Simmer.plot and related it to the capabilities of the ggplot2 package, which is very good at visualizing a dataset, such as a round-trip transportation system for mass public transportation, has also not been explored further. There are the references that we use in this paper. Thank you for your attention.